Hello there, Mr. Sutton here, bringing you the Algebra 2 2-4 homework solutions on modeling with quadratic functions. For this problem, we notice that we've got the vertex and another point. So to try and make an equation of the parabola here, I'm going to start with my vertex form. That's a times x minus h squared plus k. Let me start by plugging in the vertex that they gave me. So that's going to be x minus negative 2, so x plus 2. And then we'll still have the a there, and we've got this plus k, that's the y value of the vertex, so 6 out there. Next up, I need to solve for the a value. I'm going to get that by plugging in this other point, negative 1 comma 3, for x and y. So I'm going to rewrite this as 3 equals a times negative 1 plus 2 quantity squared plus 6. Negative 1 plus 2 is 1. Square that, you still get 1. So we really have 3 equals a plus 6, which is just going to be negative 3 when we subtract that 6. So plugging that all back in to where I had the vertex filled in here, I'm going to have y equals negative 3 x plus 2 quantity squared plus 6. On this problem, I'm trying to write the equation of the parabola shown in the graph, and the information they've given me, they've actually given me a few pieces of information. It looks like we have the x-intercepts and also the vertex. So when you're trying to find the right model, the right quadratic parabola form for this, I think it's really dealer's choice on this one. But I'm going to go with the x-intercept model just because I don't always get to do that one. And I'm very sure that these are the x-intercepts, and I'm only mostly sure that this is the vertex. So let me use y equals a times x minus p, x minus q, and we'll plug in these x-intercepts of 2 and 4 for p and q. Next up, let me find the a value by plugging in this 3 comma 4 point, which I'm pretty sure is the vertex, but I'll plug that in for x and y. So we've got 4 equals a times 3 minus 2, 3 minus 4. 3 minus 2 is 1, 3 minus 4 is negative 1, so this is negative a equals 4. So a equals negative 4. Plugging that all back in, we can write y equals negative 4, parentheses x minus 2, x minus 4. On this problem, we're writing the equation of the parabola with the x-intercepts 12 and negative 6, and also we're told it passes through 14 comma 4. Since they've given me the x-intercepts, I'm going to start by writing the intercept form of a parabola, y equals a times x minus p, x minus q, and I'll start by plugging in the 12 and the negative 6 for p and q. Those are the x-intercepts. So this can be rewritten as y equals a times x minus 12, and then x minus negative 6, or x plus 6. Now that I've got that in there, I need to find my a value, which I can do by replacing the x and the y that are still there with this other point they gave me, 14 comma 4. So the y I'm going to replace with a 4, and all the x's I'm going to replace with this 14. So now crunching the numbers here to solve for a, we've got 2 times, this is going to be 20, so that's 40. So 40a equals 4. Dividing by 40, I can write this as a equals either 0.1 or 1/10. However you want to write it. Or I could just call it 4 over 40 for now because I'm going to simplify it later. So putting that back into my formula, I've got y equals, I'm just going to commit to 1/10 on this one, and then x minus 12, x plus 6. For this problem, we want the equation of a parabola with x-intercepts 9 and 1 that goes through 0 comma negative 18. So they've actually given us the y-intercept as well, but we can't use that alone to come up with the equation. So let me use intercept form since I have those. That's y equals a times x minus p, x minus q. So I'm going to substitute 9 and 1 for p and q. And now to get the a value, I'm going to replace the x and the y with this other point they gave me, 0 and negative 18. So for my y, I've got negative 18. And then for the x's, I'm going to replace those with zeros. So this becomes negative 9 times negative 1, which is positive 9. So we have positive 9a equals negative 18. And then dividing by 9, that's going to be a equals negative 2. Plugging that back into my equation up here, I've got y equals negative 2, x minus 9, x minus 1. On this problem, I'm trying to write the equation of a parabola that passes through 13, 8 and has a vertex of 3, 2. Because they're giving me the vertex, I'm going to start with my vertex form, y equals a times x minus h squared plus k. And I'm just going to plug the vertex in immediately for h and k. So this is y equals a times x minus 3 plus 2. And now to get the a value, I have to replace the x and the y with this other point they gave me. So for y, I'm going to use 8, and I'll have a times 13 minus 3 squared plus 2. 13 minus 3 is 10. Squaring that gives me 100, so we have 100a plus 2 equals 8. And then if I subtract 2, that's 6, so we have 6 divided by 100 for my a value. And I can reduce that, which I'm going to do in a minute. So plugging this back in, I can reduce this to 3 over 50. So I've got 3 over 50 x minus 3 quantities squared plus 2. On this problem, we have a table showing the numbers in thousands of people in a city who regularly use shareable electric scooters X weeks after the scooters are introduced. We want to write a function that models the data and then predict the number of users after 32 weeks. Okay, so as time goes on, it looks like there's more and more users of these as it becomes more well known that it's a thing. So to do this problem, we're going to first go to Desmos and put this whole table of data in there, and then we'll take it from there. So let's go to Desmos. So here's Desmos. We do the little plus here to get my table and start entering values. So we've got 1, 4, 6, 10, 12, 15, 20, 24, 25, and was that it, or was there more? Nope, just up to 25. Okay. And then let me go back and put in the other stuff. So we have 1.5, 2.2, 2.4, 3.9, 5.5, 6.8, 12.3. That was quite a jump there. And then we have 16.4, and finally 17.6. Of course, it's hard to really tell what kind of a jump we've got because these x values are not going by regular intervals. To get a good picture, let's press the little magnifying glass to get a zoom fit. So here's what the data is looking like. And this is definitely not linear. If I press the regression button, I guess you could kind of sort of make it look linear, but much better would be this new quadratic regression we just learned about. So if you click this drop-down menu and go to quadratic regression, let's see how that fits. And that seems to fit quite a bit better. We might be able to do even better with the other ones, but we're not there yet in terms of the curriculum. So we've got y equals 0.026x squared, if I round that off, minus 0.016x plus 1.59, I guess that'll be a 5 there. So there's our graph. There's all that stuff I just said in terms of a rough formula. And if we want to use this to predict number of users after 32 weeks, we're going to go back to Desmos. And to recycle this function, I'm going to press this little button that exports it to its own entry here. And to make my life a little bit easier, I'm just going to rewrite this instead of y, I'm going to write this as f of x. That gives me the ability to just plug in whatever I want. And then I'll go down one more entry here and I'll do f of 32. And that automatically plugs 2 in for all the x's. So that comes out to 28.151, so whatever you want to round that off to. So that means that we've got roughly 28,151 people using these electric scooters after 32 weeks.